Hi, in this video we will see how to solve non-preemptive shortest remaining time first or non-preemptive shortest job first, that is SJF. SJF. Okay, so always step 1, Gantt chart. Here in non-preemptive, the processor doesn't has the capacity to stop or preempt a process while its execution. Consider as P1 arrives to the ready queue at 0th millisecond. It will execute completely till 9th millisecond. Processor cannot stop or preempt P1 from executing unless until its burst time is completed, that is 9th millisecond. So while drawing the Gantt chart, we have to see the average time, arrival time as well as the burst time. So first draw this. As always, starts from 0th milliseconds. Now P1 arrives at 0th milliseconds with burst time 9. In non-preemptive, P1 is not stopped, so therefore P1 till 9th millisecond. Now we have to see the first execution is completed, therefore process 9 is completed.
Hit the subscribe button and hit the bell icon to never miss an video from Future Vision BIE.
Okay, now P1 is completed its execution because it is not stopped and it is completed till 9th millisecond, as we know. Now among 9, 4, 9 and 5, which is the shortest burst time, that is 4, which is process 2. So therefore the Gantt chart next process would be P2 with 4 milliseconds. So therefore 9 plus 4, which is 13, that is 9 plus 4. Why didn't we take 4th in the first place is because the arrival time of P2 is 1, whereas arrival time of P1 is 0. So it is non-preemptive. P1 completes its execution till the complete burst time. So we cannot stop P1 from executing. But P1, 2, 3, it arrives while P1 is executing into the ready queue. So we are comparing 1, 2, 3. If at all we have some arrival time, let's say 14, and has the shortest burst time as 1, then we can't compare 14 because we are still in the 9th millisecond in the Gantt chart 13. After this we can consider 14 to be 14. After that we can compare 14 into the consideration of the shortest job first. Before that we cannot. So therefore we compare these three processes, which 4 takes up the lead. This is just an example, we don't have this. Alright, so among 9 and 5 the shortest job is 5. P3 which arrives at 3 and has 5. So therefore we take up P3 here, which is nothing but 13 plus 5, 18. Next, among all the shortest is 9, that is P2. Sorry, this is P4. This is P3, which takes up the CPU time as 9, that is 18 plus 9, 27. So as we know, the sum of all this is 27. The Gantt chart should end with 27. So therefore no error while drawing the Gantt chart. Now step 2. Calculate average waiting time. To calculate average waiting time, we have a formula, that is waiting time is equals to service time minus arrival time. Now let us see what is service time. The leftmost to the process is the service time of that process. Let's say P1 has a service time of 0, P2 has a service time of 9, P4 has a service time of 13, P3 has a service time of 18. So let's say now we have process P1, P2, P3, P4. Service time of process P1 is 0, service time of process P2 is 9, P3 is 18, P4 is 13. Now arrival time, we will be considering it from this processes. So arrival time of P1 is 0, P1 is 1, 2, 3. Therefore 0 minus 0, 9, 9 minus 1, 8, 18 minus 2, 16, 13 minus 10. The average is sum of all divided by 4. We shall use a calculator. 8 plus 16 plus 10, that is 34. 34 divided by 10 divided by 10, 3.4. Therefore average waiting time is 3.4 milliseconds. So the next step is to calculate turnaround time.
Hit the subscribe button and hit the bell icon to never miss an video from Future Vision BIE.
Okay, as we know, step 3 is turnaround time. Here we have our process, what we have calculated here. So now turnaround time is nothing but waiting time plus burst time. So from this we can know what is the waiting time, right, of all the processes from P1 to P4. We just copy that 0, 8, 16 and 10 to this. We'll calculate further. P1, P2, P3, P4. So P1's waiting time is 0 as we calculated here. 0, 8, 16 and 10. The same values from step 2 is taken down here. Now burst time. The burst time is already given in the table, that is 9495. So just we take it into this processes now. 9 plus 4 plus 9 plus 5. So equals 9 equals 12 equals 10 5 equals 15. We have calculated this. We could also calculate the average turnaround time, that is nothing but sum of all the processes divided by number of processes. So therefore average turnaround time is equals to the sum. You can just calculate here. 9 plus 12 plus 25 plus 15, that's 61. 61 divided by 4, it's nothing but 61 divided by 4 is 15.25 milliseconds average turnaround time. Okay, we need to calculate average turnaround time unless it has been asked. So do visit my website, my YouTube channel. This complete solution and other study materials are being uploaded, and don't forget to subscribe.